Okay, so we're now in recording mode, and I'm going to give you a little bit of a rundown as to what's going to be happening going forward. And what I'm saying now, I'll probably repeat again later in the session because there are not so many people here. We in midterm mode. In other words, we're completing chapter 4. As a matter of fact, these 3 problems on the board that we're going to be doing will be as a review of chapter 4, parts of things on chapter 4. One of the most important parts of chapter 4 is learning how to factor. Before I left, we had talked about adding and subtracting of polynomials. Now, then I know Patrice must have gone through multiplying polynomials and then factoring of polynomials. So, and she told me that that's what you completed. And there's only one more topic left in chapter 4. So basically, we're going to be in this starting today and continuing next week. We're going to be doing review for the midterm. Now, the whole period is not going to be review. I think that's going to be too tedious. We'll do parts of the session will be for review for the midterm, just like we're starting now, and I'll be doing examples of the type that you're going to be finding on the midterm. And then part of the session is going to be devoted to doing new material, because even though we're up to where we should be in terms of the midterm, we still have to look forward and think about what's going to be coming up ahead, which is the final. There is, first of all, somebody asked me about the work on Delta Math. What I'll do is I'll just give you an extension on the quiz and all the other homeworks. I'll just change the due dates on them. So if you haven't had a chance to do everything, you're going to have more time available. It's a good idea to do all those homeworks on Delta Math, because that will certainly help you as a review for the midterm as well. In addition to what's on Delta Math, I have posted on Blackboard in a section that's called quizzes, tests and quizzes, something called the midterm preview. It is something that was sent to me by the math department, indicating the type of problems and the type of test you expect the midterm to be. I am going to count that as a quiz or a test, as a class test. Since it's going to be something new, instead of giving you just one chance to do it, you're going to have 2 chances to do it. And the better of the 2 marks is what I'll take as your mark for the test mark. That is going to be, I'm going to have that available. I think I set it up until the 25th of October, but I'll extend it so it'll be available until the 28th. In other words, you have from now until a week from now. If you haven't looked at it yet or tried it yet, you have a week to do that preview. Now, aside from being that you have to do it because I'm counting it as a test mark, it's the best thing you can do for review of the midterm and also going ahead towards the final, because it's set up in the exact setup that the midterm will be. The midterm is going to consist of 20 multiple choice questions, and that's exactly what this midterm preview is. It's 20 multiple choice questions. You want to get used to doing a test on Blackboard. You want to see that you understand the mechanics of the whole thing, not just taking the test, because this is, you have to have some facility in taking a test on Blackboard. It's set up so that you have an hour's time to do the test. The test will be available, as I said, it's already available now and will be, this preview will be available until a week from now. But once you sit down and start it, you have to complete it in one session. Just like the Delta math quizzes have to be completed in one session, because if your time runs out, once you start working, the time clock starts and you have an hour to complete it. Again, you're going to be given 2 chances to do it. So if you don't do so well in the first chance, at least it'll give you an idea of what to expect, so you'll do better on the second time around. If you have any difficulty while you're doing the test, you can always email me. The disadvantage about doing it anytime in the next week is that I'm not always available every second to answer your questions, but I will constantly check my email and see if there are any problems. If you have a problem, sometimes you're just, the internet goes down, then it has to be reset. I'll be able to do it for you. In terms of the actual midterm, I haven't gotten it yet from the department, but I'm supposed to get it next week, so I haven't set it up so that it will be available, or I will set it up any place from October 28th through the 31st. In other words, I'm not giving you just like a test in class. If you're in a in-person class, your midterm will be at a specific time. But since this is online and we're doing it remotely, there's a little bit more flexibility, and I will set it up so that it will be available between October 28th, right after class, starting at 10 o'clock, through the 31st, which is the Monday. I'll probably put it until Monday evening. Again, you have to set yourself an hour's time aside that you can sit and do the midterm. Don't think that you can say 15 minutes, I'll go away, I'll have lunch, and I will come back. Because again, it's once you start the test, it's a timed test, and it will automatically submit after 1 hour. So you can start it anytime you want between October 28th and the 31st, but you have to make sure that you're completed it by, let's say we make it 10 o'clock in the evening on the 31st. So if anybody cannot do it in that time frame, then you're going to have to let me know, and then I will reset it up for you. Also, if anybody's entitled to additional time, I haven't gotten any notification of that, but if you are entitled for some reason for additional time, you have to let me know so I can put an extension on your test for additional time. I hope that's clear. Does anybody have a question? You can either put it on the chat or you can actually ask me, but that's where we are going forward. Okay. If there's no additional questions, then I'm going to give you, I have 3 factoring problems on the board. I'm going to right now give you 5 minutes to do those 3 problems, and then we'll discuss each of them very thoroughly, so it's a good review for the different types of factoring that you might see on the test. Okay, I think we should get started on doing these examples. And I'm going to start with number 1, which reads, first of all, the title, the instructions is to factor. So we're doing factoring on all of these. So the first one is 6x fourth y squared plus 18x cubed y cubed minus 3x squared y squared. And we want to factor. And I hope you recall that there are basically 3 different types of factoring that we can do. The first type of factoring, and it's one that we always look for, is a common factor. And what we mean by a common factor is a number or letter that goes into each of the terms of the polynomial. This is actually a trinomial. There are 3 terms, so we call it a trinomial. And if I look at, first of all, the coefficients, the numbers in the front, there's a 6, an 18, and a -3. We don't bother with the negative unless it's in front of the very first number. The first number is positive, so we don't have to worry about the negative. Of those numbers, 6, 18, and 3, the number that goes into all of them, the one that divides evenly into all of them, is the number 3. So we put it in front. Then we start looking at the variables. And we start, first let's look at the x's. There's an x fourth here, an x to the third here, and an x squared here. Now, when it comes to the letters, finding the common factor is relatively easy because it's always the one with the lowest exponent. There's an x in each one of these expressions, each of the terms. The lowest exponent I see is x squared. So that's going to be the common factor for the x's. I'm going to do the same thing with the y's, because that's my other variable. I have a y squared, a y third, and a y squared. Again, the lowest exponent I see all over is the y squared. So that's going to be our other common factor. So the first thing, and this is what we start with any type of factoring, we look for a common factor, and we look at it by looking individually at the numbers and then at each of the individual letters. Now, if this would have had a y and this would have had a y, but there's no y let's say in the third term, then y would not have been a common factor. Okay, once you've discovered what your common factor is, you then want to divide that common factor into each of the terms so that you'll get the other factor of this problem. Factor means what 2 things were multiplied. We have, it's like we're doing Jeopardy, where I said, okay, the answer is this. What did I multiply? So factoring is the undoing of multiplication. But they're not giving you one, it's not division, because in division, let's say if I tell you divide 18 by 3, you know what you're dividing by. But if I say factor 18, then you have to figure out what numbers you're trying to multiply. We're trying to find the greatest common factor. That happens to be the 3x squared y squared. Now we're going to divide it into each term. And we're going to, again, do it piece by piece. We'll divide the numbers into the numbers, the letters into the letters. So the 3 divided into the 6 gives me 2. The x squared divided into the x fourth. Okay, so how do we divide letters? We divide the like letters. It can only be an x divided by an x. And we do it by subtracting the exponents. The exponent here is 4. The exponent here is 2. 4 minus 2 is 2. So therefore, this gives me x squared, or x to the 2. The next thing we do is go to the y's. We have a y squared divided by a y squared. Now, 2 minus 2, if we're subtracting the exponents, gives me 0. Anytime you get a 0 exponent, it means there's no letters left. It just means that you have the number 1. Well, so actually that means that the y squareds are canceling out. Because if I put a 1 here, 2x squared times 1 will just give me 2x squared. The only time I actually have to put the 1 in is if everything has disappeared. But if you have something left, 1 times anything is that original number. So the first, when we divide the 3x squared y squared into the 6x fourth y squared, we get 2x squared. Now we go to the second term and do the exact same thing. The 3 divided into the 18 gives me 6. And it's a positive 3 into a positive 18, so it's a positive 6. And again, we're going to do the same thing with the letters by subtracting the exponent. This has a 3 exponent. This has a 2 exponent. 3 minus 2 is 1. So the x is going to be x to the 1. But you know that when you have x to the 1, you can just write it as plain x. Not wrong to write it x to the 1, but x, plain x will work. Now we have the y cubed divided by the y squared. Again, we're doing 3 minus 2 is 1, so that just gives me y to the 1 or y. And finally, we do 3 into negative 3, and that gives me negative 1. The x squared into the x squared cancels out. The y squared into the y squared cancels out. So the only thing that's left is the number 1. Remember, the only time you actually have to write the number 1 there is if everything canceled out. Because 1 times, it's going to be 1 times 1 times 1 actually. So your final answer comes out to be 3x squared y squared on the outside as your greatest common factor times 2x squared, it's in the parentheses, plus 6xy minus 1. Don't forget, if everything cancels out, when you're dividing and everything cancels out, you're not left with nothing. You're left with a 1. Is there any question about that question? All right, so then let's look at question number 2. That type of factoring is what we call group factoring or grouping. This is the only time that we're going to have actually a method of factoring something that's bigger than 3 terms. Unless we have a common factor, that you can take, it doesn't matter how many terms you have. But all the other factoring we're going to do will either consist of 2 terms, 3 terms or trinomial factoring, or 4 terms. This actually is 4 terms. Notice none of these can be combined because they're not like terms. And of course, like before, the first thing I'm going to do is I'm going to try and find a common factor. So I look at the numbers. There's a 4, and a 12. Those have a common factor, but 9, 4, 12, and 9 don't have any common factors altogether. 4 and 9 are totally not compatible in terms of factoring. So there's no number common factor. And if I look at the letters, they're all x. This is an x cubed, this is an x squared, this is an x, but there's no x over here. So in the whole example, there's no common factor. Again, you're going to see again and again, the first thing I'm going to do in any question is see, is there a common factor? That's the first thing we want to do. Well, when we're dealing with 4 terms and we don't have a common factor, the other thing we could do is something called grouping. Split the example into 2 pieces. The 2, so that you have, instead of 4 terms, you have 2 terms for a binomial in the front and a binomial as a second part. And look at these 2 pieces separately. This, just looking at the first 2 terms, 4x cubed plus 12x squared, that does have a common factor. There's a common factor in these first 2 terms. Between 4 and 12, the common factor is 4. And between x cubed and x squared, well, the lowest exponent there is the 2. So in the first 2 terms, we have a common factor of 4x squared. Remember, I'm ignoring this second part. I'm going to now factor out that common factor of 4x cubed, of 4x squared. So the 4 into the 4 cancels. It just leaves you 1. But x squared into x cubed, remember, we're subtracting the exponents, we're getting an exponent of 1. That means we're left with 1x to the 1, or just a plain x. Going to the second term, 4 into positive 12 gives me 3. But the x squared and the x squared cancel out. So that's taking out a common factor from the first group, the first 2 terms, the first binomial. I now go and ignore this for the meantime and look at my second group. My second group consists of negative 9x minus 27. And again, we're going to look to see if we have a common factor in that group. So between 9 and 27, of course, 9 is a common factor. But what we notice also is that the first term happens to have a negative. And when your first term of anything that you're trying to find a common factor of starts with a negative, the negative is included as part of the common factor. So instead of saying the common factor is 9, we're going to say the common factor is negative 9. I'm going to put this negative 9 in the front. And dividing negative 9 into negative 9x, of course, gives me x. And negative 9 divided into negative 27 gives me plus 3. So because I couldn't do anything with the whole thing at once, we split it into 2 groups. And we found each group had a common factor. Now here's the trick. If you then look what's inside the parentheses. In this parentheses, we have an x plus 3. In this parentheses, we also have a x plus 3. The x plus 3 is a common factor. It's not a common monomial factor, not just one term, but it's what we call a common binomial factor. Both of these terms are being multiplied by x plus 3. When you see the exact same parentheses on both of them, you can take that parentheses, the x plus 3, and take it out, so to speak, factor it out. That's going to be your first parentheses. Your second parentheses is going to be the numbers that are outside of each parentheses. In other words, first we're going to write the 4x squared. And secondly, we're going to write the -9. That's what's called factoring by grouping. We have managed to factor this 4-termed expression. There's nothing to call, there's not a way of calling a 4-termed expression anything other than 4 terms. It's a polynomial. It doesn't have a special name. By grouping, we do this specifically when we have 4 terms and we get a common factor, and this doesn't always work, but if it works, if we get the exact same thing in both parentheses, we can put that parentheses, that x plus 3 in the front, and in the second parentheses, we just put the numbers that are in front of each of those x plus 3's, the 4x squared and the -9. This is the grouping factoring. But whenever you're doing factoring, there's another thing you have to look for. After you factor, you always want to check, could I possibly factor further? And in this case, there is something else that we can do. We're up to the third type of factoring, which is called the difference of squares. Now, the difference of squares could be a problem that we could have just on our own, but in this case, it's a continuation of this problem. The x plus 3, there's nothing more that we can do with it. But the 4x squared minus 9, if you notice, the first term is a perfect square. That means you could both find two numbers that multiply by themselves to get 4x squared. Obviously, that's 2x and 2x. I'm going to write it over here. I'm going to leave the x plus 3 alone. And I'm going to the second part, which is the 4x squared minus 9. We break up the 4x squared into 2x plus 2x and 2x. Then we go to the second number, minus 9. Since this is going to be a minus 9, we're going to break that up. 9 is also a perfect square. It's 3 and 3. So my second two numbers are 3 and 3, and one will have a plus in it and one will have a minus. This basically is the only way you can factor a binomial, unless you have a common factor. But for regular factoring, to break it up into two parentheses, your first number has to be a perfect square. Something times something. Well, 4x squared is a perfect square because it's 2x times 2x. It's something times itself. That one makes it a perfect square. The second number has to be a perfect square. Well, 9 is 3 times 3. That's why it's called the difference of squares. The first is a perfect square. The second is a perfect square. And the sign in between them has to be a minus. If that, then it can be factored. If this would have been a plus, we couldn't have gone any further. But when it's a minus, we can break it up into two parentheses. And if you notice, the two parentheses look almost identical, except in one we have a plus and in one we have a minus. These are what we call conjugate binomials. Conjugate binomials are binomials that look exactly alike, except for in one parentheses you're going to have a plus and one you're going to have a minus. When you have conjugate binomials, it's always the result of factoring what we call the difference of squares. This is a perfect square and this is a perfect square, and there's a minus difference. And this would be your final answer. Because until you factored everything completely, until you can't break anything further down, that's not considered a correct factorization. Okay, so now let's go to this last example over here. This example is a trinomial. Trinomial factoring is the last kind of factoring, or the fourth kind of factoring you might encounter. Now, when it comes to a common factor, the first type, that could occur with either this, this, or this. It can, you can have a common factor together with any of the other three types of factoring. But the last three types, grouping, difference of squares, and trinomials, are totally separate. You won't have an example that is a grouping that's also a trinomial, because grouping is when you have 4 terms, not when you have 3 terms. You're not going to have difference of squares when you have trinomials, because the difference of squares is 2 terms. It's a binomial, not a trinomial. So this has 4 terms, this has 2 terms, this has 3 terms. Okay, this is 3 terms, so we're talking about trinomial factoring. But again, we always start with step number 1. Is there a common factor? And I look at the numbers. There's 3, 21, and 30. 3 goes into each one of those terms. And notice we're starting with a positive 3. So first of all, my common factor is 3. In terms of the letters, this is an A squared. This is an A, and this has no A. So there's no common factor among the variables, just the 3. So we're going to take out, we're going to factor out that 3. So 3 into 3a squared will leave me a squared. 3 into negative 21a will leave me, well, 3 into negative 21 is negative 7. And of course, the a stays because there's nothing, no a to cancel it out with. And finally, we have 3 into positive 30, which is going to give me positive 10. So that's step number 1. We have taken out the common factor. And then we're left with this trinomial inside the parentheses of a squared minus 7a plus 10. And we're going to leave our 3 on the outside. But what we're going to try and do is to break up the trinomial into 2 binomials. And when I do trinomial factoring, I really do 2 different methods, depending if whether, and I'm just looking at what's on the inside of the parentheses, if what we call the leading coefficient, the number in front of the square term is 1, or if it's not. In this case, our leading coefficient, remember, I've already taken out the 3. The 3 is no longer part of it. There's nothing in front of the a squared. The leading coefficient is 1. That's the easier type of trinomial factoring to do. Because first of all, to break up the a squared, all you have to do, there's only one way to break it up, a and a. The second thing I do is I look at the signs. Let me put a little okay. It's called the signs. When I mean the signs, I mean the plus or minus signs. If okay, there's going to be a number of possibilities. Possibility number 1. I'll give you all the possibilities, and then I'll tell you, and then we'll apply them. Possibility number 1 is in our trinomial, we have a plus and a plus. So then when we factor it, what we get is a plus in each parentheses. A plus between each term when these two terms are plus. Obviously, that's not what we have because I don't have a plus and a plus. I have a minus and a plus. So let's look at the second. We have what if we have a minus and a plus, which is what we have here. Now, you have to remember that what you're doing is you're always looking for numbers that are going to multiply to the last number and add to the middle number. So when your last number is plus, it means both numbers are going to have the same sign, which means they're both going to be, in this case, a minus and a minus. So this is a case where we have a plus as the last term, but the middle term is minus. Both signs are going to be minus. And what we're going to be looking for are two numbers that multiply to 10, but add to -7. Okay, two numbers that multiply by 10. Notice this says plus, so they have to add to -7. Well, the only two numbers I can think of that multiply to 10, and then when I combine them will give me -7 or 7, it's going to be -2 and -5. Notice I could check this because you can always check factoring by remultiplying by the a times a would give me the a squared. Remember, this is a trinomial, so we're doing FOIL. The outer is -5a. The inner is -2a, which combines to -7a. And the last is -2 times -5, which is 10. So notice when we're trying to figure out what our numbers are, we always sort of work backwards. We start at the end, and then we go this way. Multiply to 10, add to -7. Notice I'm not worried about the letters anymore because I've taken care of them. I'm just looking for the two numbers. Notice when your last term is positive and your middle term is negative, both terms are negative. Let me just do one more. That's what if you have your last term is negative. And the first term could either be positive or negative. The middle sign, in this case, when your last term is negative, and we're going to do a couple of those in a minute, the middle term can either be positive or negative. If you have a negative as your last term, in your parentheses, one of the numbers is going to have a positive and one is going to be a negative, and it doesn't matter which one is first and which one is second. So we should keep in mind when we're factoring trinomials to look at the signs to make sure we're getting the right sign. But basically, the whole thing depends on multiplying to the last number and combining to the middle number. And that's how we multiply things. Again, this is when our leading coefficient is 1. So now, this is the final answer to the last question. Again, first we had to find our common factor, and then we factored our trinomial. Is there any questions about any of this? Okay, I am going to put 3 more examples of trinomial factoring on the board. And I'm going to give you a couple of minutes to try them. And then we'll continue. I'm going to take attendance a little bit later because I see people are still sort of straggling in. Okay, I know this got a little bit messy, but as I said, whenever we're going to be doing the factoring, our first thing is always to look for that common factor. And then we decide which of the three other types it is, depending on how many terms we have. In grouping, we have 4 terms. Difference of squares, we only have 2 terms. And in trinomials, of course, we always have 3 terms. Okay, is everybody okay if I erase what's on the board now? Anybody still need the stuff on the board? Okay. Again, just to solidify the things that we were talking about, let's factor these examples. One trinomials, since trinomials are really, they're not, you have to sort of think about them more. I'm doing the trinomials. And I want you to factor each of these, what we say, completely, which means first look for a common factor and then go further. Another one that we might want to do. Give you a few minutes for that. Okay, I think maybe we should get started with these, and we'll do them slowly so you get a feel for them. And then I'm going to leave the factoring, and I'm going to talk about something new that involves using factoring. On Monday, I will review another type of trinomial factoring, but I'm not going to do it today because I think it's just going to be too confusing now. If I look at my first example, again, it's a trinomial, it's 3 terms, and there's no common factor because, first of all, the leading coefficient, the number in front of the x squared, there isn't a number there, is understood to be 1. We don't talk about 1 being a common factor. And in terms of the x's, the last term doesn't have an x. So there's no common factor. Again, the first step in any type of factoring is to check, is there a common factor? So then we're on to our trinomial factoring, which means we're going to break it up into, or try to break it up, not everything is factorable, into 2 parentheses. And since, as I said, our leading coefficient is 1, and I'm only going to be dealing with examples where the leading coefficient is 1 today. The only thing I can do with the x squared is break it up into x and x. I can now remember my rules for the signs. The last sign is positive. Let me give you the reasoning behind what's happening here. Remember, we're looking for numbers that multiply to a positive 20. Now, in order to multiply to a positive number, either both numbers are going to be positive or both numbers are going to be negative, because if it was a positive and a negative in here, then this would have been a negative sign. So it's got to be either 2 pluses or 2 minuses. But since the first term, the middle term, remember, I look at the last one first. If the last one is positive, we look at the middle one. It means both of them are going to have to be positive. And now, again, we start at the end. We look for 2 numbers that are going to multiply to 20. But when we add them, they're going to add to 12. Well, I know what those 2 numbers are. It has to be 10 and 2, because 2 times 10 is 20. That'll give me the 20. And 2 plus 12 is 2 plus 10 is going to give me the 12. So in one I put the 10, and in one I put the 2. Again, I've already taken care of the signs. Don't forget, when everything is positive, your 2 signs are also going to be positive. If you had written x plus 2 in the first parentheses and x plus 10 in the second, that would have been totally okay. You can change the order of the parentheses all the time. Can't always change the signs, but the order, you can always put 1 parenthesis first and 1 parenthesis second. You switch it, it's perfectly fine. Okay, so now let's look at the second example. And again, my first step is to look for a common factor. So there's a 4, 8, and 12. Remember, I'm really concentrating just on the numbers, not on the signs. As long as that first number is positive, we're going to keep the common factor positive. And obviously 4 goes into each of them, so 4 is a common factor. Then we look at the letters. X cubed, x squared, x. They all have x's, so there's a common factor of x. The lowest exponent we see is just the x alone, which means x to the 1. So x is going to be the common factor. So we have in this whole expression a common factor of 4x. Now we're going to see what we're going to be left with in the inside. Remember, when we take out a common factor, after we've decided what the common factor is, we divide it into each term. So 4 divided into 4 cancels. x into x cubed. Remember, when we're dividing the letters, we're subtracting exponents. This is an exponent of 3. There's no exponent here, it means it's 1. So 3 minus 1 is 2. That leaves me x to the 2, or x squared. Going into the next term, 4 into negative 8 gives me negative 2. X into x squared, again, we're subtracting exponents. 2 minus 1 is 1. So it's going to leave me with x to the 1, or just plain x. And finally, 4 into negative 12 gives me negative 3. And x into x, remember now it's 1 minus 1. When my exponent is 0, it really means that the answer is just a plain number 1. So we don't, in other words, the x canceled out. So step number 1, we've taken out our common factor of 4x. We're left with, inside the parentheses, x squared minus 2x minus 3. So we've been left with a trinomial. Once we're left with a trinomial, remember, what common factor can go with any one of the other 3 types of factoring. We're going to leave this 4x alone, but we're going to try and break this trinomial into its 2 binomials. Again, now if I just look at the inside of the parentheses, the number in front of the x squared, well, there's no number there, means it's 1, which means that breaks up into x and x. What we notice is that my last term, remember, I go to the last term, my last term is negative. The only time we can get a negative, remember, we're multiplying 2 numbers to get negative 3, which means one has to be a plus and one has to be a minus. When the last term is negative, one of the signs is going to be positive, one's going to be negative. And what we're looking for are 2 numbers that when we multiply them will give us negative 3, but when we combine them will give us negative 2. Now, since we're multiplying, we're getting a negative number, and what meaning one number is going to be positive and one number is going to be negative, instead of adding to the middle number, they really have to subtract, because when you add numbers with different signs, you actually are subtracting. So really, what I'm looking for are 2 numbers that multiply to 3, but when I subtract them, this is going to give us a clue. It's going to give us 2. And obviously that's 3 and 1, because 3 times 1 is 3, but 3 minus 1 is 2. Now here we have to be, so we know that we're dealing with the numbers 1 and 3. Now we're going to have to be careful. We have to be careful because I can't, when both signs are the same, it won't make a difference which number I put, because they're both going to be either plus or they're both going to be minus. But when one number is going to be positive and one's going to be negative, we have to be careful as to which goes with a positive sign and which one goes with a negative sign. And if you remember, when you're adding numbers that have different signs, for example, if you're adding a negative 8 and a positive 11, you're really doing the 11 minus the 8, which is going to be 3. And since the bigger number is positive, your answer would be positive 3. You always take as your sign the sign of the larger number. That being the case, since that middle sign, so let's go back to this one. We know we have 2 numbers, 1 and 3. I have to know, should I put the one with the plus or should I put the one with a minus? Well, the middle term is negative. That means that the larger number had to have been the negative, because that's the only way it works, is if you always take the sign of the larger number. The larger number here happens to be the 3, so the 3 has to be the negative, which means the 1 goes with a positive. And if you do the FOIL, you'll see that that really works because x times x will give you x squared. Outer would give you negative 3x, and inner would give you positive 1x, and negative 3x plus 1x gives you the negative 2x. And last is positive 1 times negative 3, which is negative 3. So when your last term is negative, you know you're going to have a plus and a minus, and you look at the middle term, and whatever sign the middle term is, that's the sign that the bigger number is going to be attached to. Okay, so this is this factored completely. Again, look for that common factor and then go further. Let's look at this last one. Again, there's no common factor for all three terms. Again, it's a trinomial. So again, we're going to make our two parentheses. And again, we're starting with an x squared, means we're going to have an x and an x. And again, we can worry about or decide on the signs. Since the last term is positive, it means both are going to be positive or both are going to be negative. This negative in the middle tells us both are going to be negative. And now we're looking for two numbers that when we multiply them give us 6, but add to 5, obviously that's 2 and 3. And since these are both negatives, it doesn't matter where I put the 2 and where I put the 3. So when the last term is negative, you really have to be a little bit more cautious. When the middle term is positive, it really goes multiply to the end, add to the middle, and let the signs be determined by that sign of that middle term. Okay. I'm going to now talk about the last topic that we have here in this chapter. And that is something called quadratic equations. Let me stop here and just remind you what I had said at the very beginning of the term, of the lesson. I have done a review of all the types of factoring you could do, except if you have a number in front of the x squared. That I'm going to review on Monday. We're going on to the last topic that's going to be covered in the midterm. That topic is something called quadratic equations. Quadratic equations. And that's what we're going to be discussing for the rest of this period. Again, the next week, we're going to be spending half the period doing review, just sort of like what we were doing now, going back to the very beginning of the term. And half the period we're going to be spending doing some new material, because we can't neglect the new material because we still are going to have a final exam to do. The midterm is, well, let's talk about the midterm. I'm going to, I haven't gotten it from the department yet, but I assume by next week I will have it. It's going to be posted on Blackboard. The midterm and the midterm preview are on Blackboard. They are not on Delta Math. There is a quiz on Delta Math that you're supposed to have done. I'm going to extend the due dates on all the things that I've given you. So therefore you can continue. If you, on the homeworks, it doesn't matter. Whether you get, every homework is available until the end of the term. You might get only 90% of the credit if you do it late, but for homework, that doesn't matter. When it comes to homework, did you do it or didn't you do it is what counts. I'm going to extend the due dates on the quizzes that I've given you. I'll probably extend them till the end of the term because I know it's been a little bit of a choppy term for you this term. So, however, the midterm itself is not given on Delta Math. It is given on Blackboard. Right now, I have posted on Blackboard a midterm preview. It's a test that is very similar to what you're going to find on your midterm. It's got the same exact setup, the way the midterm is going to be presented. If you go to your Blackboard account from Math 136-006C, you will see one of the topics there, one of the headings is tests and quizzes. You probably didn't, if you haven't opened it up recently, you might not have seen that. It's just, I just recently opened it. If you click on that section, you will see the midterm tests. And if you'll start, it will give you an option to start the test. Once you start the test, you have an hour to complete it. It must be completed in one session. I'm going to, as I said, I think I have it's already available. I think I made it available until October 25th, but I'll extend the availability. I'll extend the due date on it. I'm giving you 2 chances to do that midterm preview. Whichever mark is better, that's the mark you're going to get as it's going to be considered a class quiz. So it's not as if you do it just for the fun of it. It is a requirement of the class, you must do it. That's the midterm preview. The midterm itself will be in a section in Blackboard called midterm, which is probably not open for you yet. I haven't, because it's not posted yet. It will be available starting right after this class on Friday, on the 28th, and you will have through the 31st to complete the midterm. Again, that doesn't mean you can start and stop. Once you start it, you've got to complete it. It's got to be completed by October 31st, which means if it says, I said 10 p.m. is going to be the close of it, means you have to start it at least an hour previous to the final time available. Again, I'm giving you a broad range of times to work on it because I know everybody has different schedules. If that doesn't work for you, that between the 28th and the 31st, you can't find an hour to sit down to do that midterm, you gotta let me know so I can set up a special session for you. If you run into problems with your internet or something, or it shuts down, and that the point of doing the preview is that you should practice how this thing works, then you've got to email me and I will reset it. Now, if I were just giving you 2 hours or so of a broad, say you've got to do it, let's say between 10 and 12 on October 28th, then I can be available that whole time. But again, I don't know what everybody's schedule is. So I'm giving you a larger span of time to do it in. So if I don't, check my emails relatively regularly, but it might be that you'll email me on the 29th and I won't answer you until 5 hours later, but I will answer you and I will reset it for you. Again, if you are entitled to extra time, or if you have any difficulty, just email me. Again, that is, as I said, you're going to have 2 chances to do the preview. Of course, the midterm is 1 chance. It's a midterm given by the department. All right. With that, having said that, let me just talk about what a quadratic equation is. Until now, the type of equations we were dealing with was something called linear equations or first degree equations. None of the equations that we solved, remember, solving an equation means you have an equal sign in the example, and you're trying to find out the value of x. We've done linear equations, and we've done absolute value equations. When we did linear equations, remember, we got all the x's or a variable, whatever the variable is, to one side. We got all the numbers on the other side. And then we divided by the coefficient of the x, and it gave us our one answer. That is, there were no exponents, nothing, just what we call first degree. The highest exponent was a 1. A quadratic equation is also something called a second degree equation, which means that we're going to have an exponent of 2. In other words, we're going to have an x squared. And the way we solve quadratic equations is very different from the way we solve linear equations. We're going to learn one method now. Later on in the term, we're going to learn some other methods that might work. Because not the method I'm going to teach you now is not always, doesn't always work. Let's try something like this. Suppose I gave you this quadratic equation, x squared minus 12x plus 35 equals 0. First of all, I recognize this as a quadratic equation because it has an x squared in it. It has an exponent of 2. It's also an equation because it has an equal sign. It's not just an expression like what we've been dealing with until now. We've just been working with expressions. This is an equation. An equation means something that's equal. So we have to have an equal sign. When we have quadratic equations, we want to make sure that all our terms are on one side of the equation. Usually we bring it to the left side. And the other side has a 0. It's all on one side equaling the 0. If it's not in that form, and I'll recognize it as a quadratic equation because it'll have an x squared in it, I'll have to bring everything to one side of the equation. All right, we're starting with this being on one side of the equation. And if you notice, what we have is a trinomial. And trinomials, we know how to factor. That's what we're going to do. We're going to factor this expression that's on the left side of the equation. Now, if it's just 2 terms, then we have to factor it the way we factor binomials. If it's 3 terms, we factor it the way we factor trinomials. We know when we're factoring trinomials, we first look for a common factor. There isn't one. So then we try and break it up into 2 parentheses. And we'll just leave it still equal to the 0. And of course, the x squared breaks up into x and x. And remember, we look at our last term. Our last term is positive, which means that's the easier type of factoring because both numbers are going to either have to be positive or both of them are going to have to be negative. Since the middle term is negative, that means that both of them have to be negative. And we're looking for 2 numbers that multiply to 35. But when I add them, give me the 12. Okay, the only thing I know that multiplies to 35, besides 35 and 1, is 7 times 5. And guess what? 7 times 5 does add up to 12. So that's the proper factoring. One, we're going to put a 7, and one we're going to 5. So the first step is just regular factoring. Factor it out. If it's trinomial, do our trinomial factor. Now, look what we have here. X minus 7 is one number. X minus 5 is some other number. Let's say X is 22. Then this would be 22 minus 7, and this would be 22 minus 5. They're two different numbers. What do we know about these two different numbers? This number in this parentheses times this number in this parentheses. We're multiplying them and we're getting 0. Now, when you multiply two numbers to get 0, very special. 0 is a very special number. When you get 0 as an answer, when you multiply, it must mean that one of the numbers is 0. The only way you get 0 when you multiply two numbers is if you're multiplying one of the numbers by 0. Now remember, this parenthesis represents one number. This parenthesis represents another number. What are the possibilities? The first number, the x minus 7, could equal 0. The other possibilities, you can write or, but you don't really have to write this in. This other possibility is that the x minus 5 equals 0. The whole point of setting up, making sure that our quadratic equation is set up equal to 0 is that so that we can, when we factor it, we can separately make each of the factors equal to 0. Now, what's accomplished is that I started with a complicated equation and broken it down to two simple equations. I can solve this equation, x minus 7 equals 0. I just add 7 to both sides, will give me x equals 7. And x minus 5 equals 0, I can solve by adding 5 to both sides. And that gives me x equal to 5. Notice I'm getting two answers for x. One answer, and you could sometimes see it in these braces. One answer is 5, one answer is 7. Just like in absolute value equations, we got two answers. In quadratic equations, we get two answers. General rule, the degree, the highest exponent tells you how many answers you should get. If your degree is 1, you get one answer. If your degree is 2, you get two answers. If we would have had an x to the 7th in our equation, we could have been looking for 7 answers. So the number of answers depends on the degree. But the way we solve quadratic equations is to factor and separate the factors, separate the parentheses into different answers to get us our different answers. Okay, let's try another example. I'm going to do one more, and then I'll give you one to try on your own. Okay, let's look at this example. X squared plus 5x equals 6. Now, and again, we're trying to solve it's going to say solve because this is an equation. And I know it's an equation because I see that equal sign. And not only that, I know it's a quadratic equation because it has an x squared. So remember what I told you to do. When it says that it's a quadratic equation, you have to get it equal to 0. People sometimes tell me, oh, they recognize that it's a quadratic equation because it equals 0. Not only are they equal to 0, we have to make sure it's equal to 0. And the reason we know it's a quadratic equation is because we see an exponent of 2. Okay, so that means I've got to get this 6 to the other side. So I'm going to subtract 6 from here, which means I've got to subtract 6 from here, which is giving me x squared plus 5x minus 6 equaling 0. So now I have it in the proper setup for a quadratic equation. Notice I always want to have it in the order of the x squared term, then the x, then the number equaling 0. And after I've got it in the proper setup, now I can factor. Now I can break it up into 2 parentheses. Okay, again, we're factoring. This is a trinomial, so we're taking the x squared and making it x and x. And remember, then we look at our last term. And notice this is a little bit of the harder type of factoring because the last term is negative. That means one of the numbers has to be a plus and one of them has to be a minus. And now we're looking for numbers that multiply to 6, but when I subtract them, give me 5. Now notice, this is a minus, so they have to subtract the 5, not add to 5, which means the numbers are 1 and 6. 2 and 3 won't work because when I do 2 minus, remember, you're going to have different signs. So I'm going to be subtracting them and I'm going to get 1. I don't want to get 1, I want to get 5. So the correct numbers are 1 and 6. And since the middle number is positive, that means the larger number has to go with the positive. So the 6 is going to go here and the 1 is going to go here. Again, you can always do FOIL to make sure you factor correctly. Notice if we did FOIL, we get x times x, which would give me x squared. Then we do outer, which would give me negative 1x. And inner, which would give me plus 6x. And negative 1x plus 6x gives us the positive 5x. And last is 6 times negative 1, which is negative 6. So I have factored correctly. Again, if you have time, you can always check your factoring by going back to FOIL. Okay, once I've got a factor, I don't stop here because this is a quadratic equation. It's a solve. It's an equation. That means I have to get a value for x. I can't just get parentheses. I separate each of the parentheses and set them each equal to 0. So I do the x plus 6 equal to 0, the x minus 1 equal to 0. And here I bring the 6 to the other side. So one answer is x equals negative 6. And here I have to do plus 1. So I get x equal to 1. So my two answers are negative 6 and 1. Again, two answers because it's a quadratic equation. So if you know how to factor, you really know how to solve a quadratic equation. Okay, I'm going to give you a problem to try by yourself so that, and while you're doing that, I'm going to take attendance. Okay. Do one more problem, and then we'll be, I think we're in good shape. Again, notice it's a quadratic equation because it has an x squared. See if you can solve this one. I take attendance. August, Olivia August, Olivia, Isis.
I'm here. Good morning.
Hi, good morning. Good to have you back. Okay, today is 10:21. Alvaro. Lewis Hart. Emma. Demetrius. Desmond. Shania. Ricardo. Kayla. Kayla, I think, is here.
Yeah.
Hi, good morning. Sanjita. Sanjita Hussein. Oriana.
I'm here.
Hi, I did know that you were here. Tahira. Hi. I know Tahira is here. I remember her from before. And I saw that, Emily. Thank you. I'm sorry, Emma. Michaela. Kiana. Carly. Jenna. Tatiana. Naya. Kazandu.
Good morning, Professor. I'm here.
Hi, good. Trina Small. Jean. Somebody. Oh, Jenna, you're here. Okay, great. Okay. I think that's everybody. I hope we'll have a better turnout starting next week. Okay, let's just do this problem. Again, it says solve. I know it's a quadratic equation because it has an x squared, which means I have to get it equal to 0. Even if it's not equal to 0, I have to get it equal to 0. Which means I have to get this 12x to the other side. Now, when I'm bringing it to the other side, I want to end up with the terms in what we call descending order, the x squared first, then the x, then the number. So instead of putting it at the end, I'm going to put this in the middle so that I get it in the right order. Remember, I can shift things around because it doesn't matter what order they're in. But for factoring purposes, we really want to have it in the correct order. So the first thing in solving a quadratic equation is to make sure everything is on one side in descending order, equaling 0. The second step is to factor. And there is no common factor again, because we're just starting with a plain x squared. So therefore, we're going to do our regular factoring. We're going to break the x squared into x and x. And this is the easier type of factoring because the last term is positive, means both numbers have to be the same. They're in the middle, they're both is minus, they're both gonna be minus. So when the last term is positive, either you're gonna have two pluses or two minuses, which you'll determine by looking at the middle term. And now you're looking for two numbers that multiply to 20. We always remember, we start at the back and move ourselves towards the front. They multiply to 20. This is positive, so they add to 12. Well, that's 10 and 2. So I'm going to put a 10 in one and a 2 in the other. Since they're both minus, it doesn't matter where I put the 10 and where I put the 2. And now I separate it and I get x minus 10 equals 0. And x minus 2 equal to 0. Here I add 10. So that gives me x equal to 10. And here I add 2. And I get x equal to 2. So our two answers are 10 and 2. Again, if you know how to do factoring, you can solve a quadratic equation, but don't forget it's an equation, so you have to go a little bit further. You don't stop here where you finish the factoring. You go further. How do you know? Because there's an equal sign and it will say solve. Is everybody okay with this? Any questions about what to do over there? Give me a minute. Okay, Patrice, could I meet with you on Zoom for a few minutes? Hello?
I'm right here. I'm here.
Yeah, okay, I'm gonna close this and reopen.
Okay, no problem.
Thanks.
Yeah.